Hi, YouTube. I'm Varun Grover, data resiliency and AI expert here at Veritas. Today, I'm joined by my fantastic friend and colleague, Jayant Thomas, distinguished engineer working on AI. Let's talk about retrieval augmented generation, or RAG. We've had some conversations on this channel already what fundamentally RAG is, but I would love to better understand from you as you think about RAG in terms of enterprise use cases. What are some of the opportunities there, and what are some of the, let's call it, challenges?
I think that's a great question. When you think of enterprise, you're looking at high quality answers. So you want to make sure the answers you're producing from your chatbot or your NLP interface is highly accurate and trustworthy. So that's where RAG comes in. And also, a lot of times, the context you're dealing with is not there in the LLMs itself, because LLM, as you know, is trained in large data sets. It doesn't have the context of your database or your other nuances. So RAG comes in very handy for those two purposes, where you impart the new knowledge into the LLM with your own context and ask the question to the LLM. Hey, the similar question, it still has the capabilities to answer with your data set. So that's a part of RAG, and it's used for answering very accurate questions and then fine tuning the LLM using your own data set.
Well said. I think you touched upon some key challenges or limitations with public LLMs like the knowledge cutoff or access to real time information and enterprise data. But not all RAG applications are created equal, as you and I both know. And so, what do you think about when it comes to the retrieval component versus the generation component within RAG? How do you think about the relative importance of those two, and what should be the key considerations when building a good RAG system?
So absolutely, that's I think like you correctly pointed out, the retrieval component is so important for the success of the RAG-enabled application. So you need to put a lot of effort in curating that information. So it could be sourced from your various different data sets you may have, parse it, and then catalog it. It's almost like an internal catalog of data. You store it in your vector database, and then you should have metadata associated with it. You should be able to retrieve it depending on the situation, so only limited to certain surface area or metadata. So you want to, like, for example, you want to limit your question to certain versions because of your product, because there could be nuances within the product set. So you can use using the metadata, you can limit it to that. So that's the important thing, to how do you store it. And the other component is how do you, the algorithms to retrieve it. There are many different algorithms, like cosine similarities, like BM25 from Elasticsearch, other things. You need to pay close attention to it. Or do you want a hybrid search? You want a keyword versus similarity search. You need to go through a strict evaluation process for the retrieval as well, so that your end product is much more accurate and concise. Yeah.
Awesome. Now let's talk about the flip side of that, which is fine tuning, which a lot of enterprises are trying to decide between fine tuning and RAG. How should our viewers think about fine tuning?
So we talked about RAG a little bit. So one of the problems with RAG is, like, you need to stuff in this large context into the every request, and then ask the LLM for answers. Instead, the other option is to fine tune. For example, you can create a large label data set, and then sort of use it to fine tune your LLM for certain specific tasks. It could also, you may also have compliance requirements. Those are some of the reason you want to start thinking of fine tuning. So once you start thinking of fine tuning, you have a couple of options, like there, all the way from prompt fine tuning. So you can use a few shot learning for simple use cases, all the way to instruction based fine tuning, where you're trying to fine tune the entire model. That's not applicable for very large models like GPT-4 and 3.5. You don't have the source code to sort of tune the entire model set. So in smaller models where you want high response time and other things, you can use the data set you created to fine tune the entire instruction. But it still requires a lot of compute. So you had to have a big GPU cluster and rebuild the entire model itself. So you then fall into the third option, which is parameter efficient fine tuning, where you're freezing the base layers of your core LLM, and then you're sort of fine tuning the last layer alone for your specific task. So then you have few other options in parameter efficient fine tuning as well, like LoRa, where you're not fine-tuning the entire like model parameter, you're taking a subset of these parameters, and then you're using that to train it. So that creates another like base layer, and then when you do the inference, you go through the LoRa layer as well. Then you also have something called QLoRa, so which is basically a even more highly efficient way of fine tuning, which is basically it uses a precision. Like instead of using eight-digit precision, you're using 4-digit precision. So those are the options in front of you, depending on which direction you want to go. You can go all of those routes. So we have tried out with fine tuning. One of the guidelines I would provide is when you do the fine tune, compare that with your RAG-enabled model, a high-performance model like GPT-4 may be able to perform much better than like a fine-tuned model. There's also a cost element to it. So when you fine-tune, you need to host this entire model set yourself, and there is an additional cost versus like using a pre-hosted model as well.
You're talking to a Gen AI Pro when the conversation goes to PEFT and LoRa, right? So thank you for sharing your insights there, JT. And how should someone think about RAG versus fine-tuning when it comes to cost?
So yeah, absolutely. So in case of RAG, you're looking at the request cost per request, because these large models, you're not hosting it. You're sort of like renting it from a cloud provider or from OpenAI or from Anthropic or any one of those providers or Mistral. So you're looking at request and the input and output tokens. Like what is the amount of input tokens you're feeding into the model? Usually it's like all the way, the newest model, you can feed up to 200K input, or it could be a smaller input, only 2K input as well. So you pay for the token you're feeding in. And then the output tokens. So you have to look at like how much output you're getting, and you're paying for that as well. So usually that's not too expensive, but if you're going and hosting your own model, that's a lot more expensive. You need to look at the GPU. You're hosting, like for example, you're hosting your open source fine-tuned model. Then you need to consider the infrastructure cost, like GPU infrastructure, the runtime inference engine, the training cost. All of those things will add up to it. But you're not paying for a per request type thing. If you have a large footprint, for example, if you know your customer base is pretty large, you're going to get a lot of requests coming in, then you can consider a PTU or pay, your dedicated instance. You can say, hey, go to a cloud provider and get a dedicated instance for yourself. So it depends on your load. You need to balance out how much you can spend and how much you can commit to during. That's one of the analysis you need to go into that.
Well said. And GPUs don't come cheap, right? So I think there's a huge backlog right now for anybody who's trying to get a GPU as well. But thank you for joining me today. If you found this discussion helpful, like, subscribe, and hit that notification bell for more valuable AI content.